So to wrap up this lesson on inverse functions, we're going to do a little bit of graphing. And just as a reminder, there are many ways that you can come up with a graph of a function. Maybe you come up with a table, a list of points, and graph those. Maybe you use a calculator or Desmos, or maybe you just know some properties about that function. For example, I know this is just a line because it just has an x. This is the y-intercept, and this is the slope. So I can graph it pretty easily. If I start at -1, that's my y-intercept. It has a slope of 1/2, so I'll go up 1 over 2, up 1 over 2, up 1 over 2, and so on, and there's my line. It also asked me to graph its inverse on the same graph, and so I might try to draw a line that's a reflection of this across the line y equals x, but it's kind of hard to be precise when you do that. So what I would recommend is pick some points along this function and flip them, because that will be a point in your inverse graph. For example, let's say this function has the point 2, 0. So my inverse function would have the point 0, 2. There's also the point 4, 1. So my inverse function would have 1, 4. And that's enough to make a line if I want to. I'm just going to do a few more just to be a little more precise. So if I have the point 0, -1, then my inverse function will have the point -1, 0. And let's connect those. And you can see how those are a reflection across the line y equals x. Ooh. I tried. Close enough. But you can see how they are a reflection of each other. All right, there are other ways to do this, so let me show you one way you could do it if you don't want to graph it all by hand, is you could use Desmos to help you out. So I put this into Desmos. Remember, this is linked on Google Classroom, or just go to desmos.com. I put in my equation here, and so there the line is graphed for me. And then if I wanted to find the inverse, I could just, again, pick a couple of these points and flip them, like 2, 0, or 0, -1. Just flip them, and you can graph your inverse from there on your paper. Another way is you could use a graphing calculator. So let me attempt to hold this up to the screen here. All right, here's a graphing calculator, nice TI-84. Remember, the way you do all the graphing is all these 5 buttons up here. So if I go to y equals, I can type in my equation, which was -1 plus 1/2 x. There it is. And then you can hit graph. If you need to, go zoom 6 to get to that standard screen. Then hit graph, and there's my graph. It's kind of hard to see what's going on there, so I highly recommend using the table, especially in this case. The table is right above graph. All you have to do is do second table, and then it pulls up a list of points that you could graph for your function. Then to get the inverse, just flip those points, flip the table. So feel free to use any of those tools, or you can use your calculator, Desmos, just graph it by hand. You can even just plug in some points and see what you get out for y and plot those points. You don't even need a calculator. All right, let's take a look at one more graph. So in this one, it's kind of complicated. It's like this weird snake thing. I'm not going to try to come up with an equation for that. All I need to do to graph the inverse is take some points and flip them. I could try my best to guess what this would look like, something like that, but that may not be very accurate. So I wouldn't recommend just trying to flip it. That usually doesn't go very well. What I'm going to do instead is pick some points like 0, 2, and flip it for the inverse, so 2, 0. Or this is the point 6, 1. So I'll graph the point 1, 6 for the inverse. 1, 2, 3, 4, 5, 6. There's some others here, like 3, 1 would become 1, 3. Or on the other side, we've got like negative 1, 2, 3, 4, negative 1. So negative 4, negative 1 would become negative 1, negative 4. All right, let's see if that's enough for me to try to conjure up this reflection image. So it would look something like this. I tried. Yeah, that looks pretty good. So I just connected the points, trying to make a graph that looked like this one, but flipped across the line y equals x. And we did a pretty decent job. You can always flip some more points if you need. All right, so on the practice, what you're going to do is graph this function plus its inverse on the same grid, and then graph this function and its inverse on a separate grid, and then graph this function and this inverse. Feel free to use a graphing calculator or Desmos to graph the original and then to find some points that you can then just flip. That's really all you need to do.